everyone. Good morning and welcome to our webinar, Building a Secure Digital Industry. I'm Thais, and I would like to remind everyone that this session is being recorded, and all of you who are here will receive the recording in the next few days. I ask all of you to remain in the mute mode, and if you have any doubts, questions can be asked via the Q&A field and will be answered at the end of the webinar. And in our webinar today, we are talking about the concepts and practices of Industry 4.0. What are the most common types of attacks within it and why? How to manage devices and care for your company's secret information, and how to reduce operational costs and leverage products. And for all that, today we have two experts, David Muniz and Glenn Merrill. David Muniz, who has more than 10 years of experience in Brazil and Europe, and has been working at Senha Segura since 2017, helping companies to address numerous aspects in cybersecurity. And our special guest, Mr. Merrill, who is a senior industry consultant and an ISA certificate automation professional with over 35 years of cross-sector multidiscipline expertise in industrial control systems. Good morning and welcome, David and Mr. Merrill. How are you guys?
I'm excellent, Thais. Thank you very much for the introduction.
Good morning. Quite well. Thank you.
Good morning. Have a great webinar, guys.
Thank you. So without further ado, let's start our session today, building a secure digital industry. And our agenda for this session. So we'll take a look at the new digital transformation landscape. We will also see the concepts that are associated with Industry 4.0. We'll take a look at the evolution of industrial systems and also the increasing cyber threats. And finally, my friend Glenn will introduce the ISA 62443 standards and how they help ensuring cybersecurity in industrial organizations. So we see I think everybody has heard about digital transformation. It's a hype word currently, and in the recent years, this whole digital transformation process is no longer a matter of if it will happen, but when this will happen. And technology has dramatically affected all business sectors, not only startups or high digitalized segments, but also segments, older segments, and segments with more maturity. And digital transformation has been changing the market and organizations of all sizes. This whole digital transformation process has come to change how we live, how we work. The models that are based in zero trust, for example, no longer consider the security perimeter as we had before. So before we had the trust but verify, and this has changed to the never trust, always verify models. And in fact, currently with the cloud models and remote working, this perimeter does not exist anymore. And with the pandemic, the issue of protecting the remote access has certainly become more critical. And again, this applies for companies of all segments and size. And regarding the post-COVID recovery, I believe that most countries are now opening to not only opening their borders, but also people are interacting more. We are now reaching the new normal. And I really believe that we're going to have this new normal with hybrid work models and mixing with in-face and remote work. Well, less than a decade ago, the organizations that are related to industrial markets, they only operated with what we call the OT, the operational technology, to manage their devices, their equipment, and also not only the functions of monitoring, but also production and logistics. Since 2013, the market has been promoting, but even before that, but in 2013 was when the term Industry 4.0 was created, and since then the market has been promoted a new industrial revolution, and this new industrial revolution is based on new digital technology to improve industrial processes, and this includes Internet of Things, industrial Internet of Things as well, automation. What in this automation field is what we call the robotic process automation, and also the privileged task automations. And this also includes smart cities, smart homes. So we have the whole infrastructure of the cities that are now connected to the internet. We have cities that have traffic lights, that have a series of sensors to help the society to have, well, a better life. That's what we expect of one of the benefits of Industry 4.0 and Internet of Things. And then the new revolution, one of the effects that this new revolution there has is the increase of the connected devices. So we talked about smart cities, smart homes, we got smart TVs, smart fridges, everything now is smart. Nothing is what we call dumb anymore. Gartner estimates that the number of connected devices will reach 24 billion by the end of 2021, which was an increase of 20% compared to 2020. So the digital transformation has brought a significant change in the OT environment. Systems that before they were isolated, now they are now connected. And this is an issue because those systems, they were not designed to be connected, and they did not have what we call security by design. And this fact increases the attack surface because it leaves the systems vulnerable to a cyber attack. And the increased connectivity of OT systems also brought an alignment with the IT infrastructure, which resulted in a bigger complexity of the infrastructure. And this collaboration between OT and IT creates new challenges in cybersecurity, and this directly impacts all companies that adopt what we call Industry 4.0. According to KPMG, the most important segments inside of OT systems are what we call the smart cities and the connected infrastructure. And also we have all the wearables, we have smartwatches, we have medical devices that are connected. And if we stop to think the amount of data that is processed on those devices, and also personal data, of course, and this data needs to be protected. And finally, we have utilities that is inside what we call the critical infrastructure. And well, this is basically, if you heard the news about the war of Russia and Ukraine, this is something that governments are investing a lot to perform cyber attacks and to affect the operations of what we call critical infrastructure. That includes utilities, the financial market, agriculture, for example. Those are some of the segments that are connected, that are inserted in the what we call critical infrastructure. So are we waiting a lot? Are we expecting a lot from Industry 4.0 and Industrial Internet of Things? Well, actually, in all of the previous revolutions, so we have the first industrial revolution, the second, the third. The first is where we had the first water and steam powered facilities. Then we had electricity in the second industrial revolution. On the third, we had electronic and IT to achieve automation of manufacturing. And now we have the fourth industrial revolution that are pretty much based on cyber-physical systems. And of course, I invited you to insert your comments on the Q&A and also to tell us a little bit more about how your company is doing. Do you work on an Industry 4.0 company? Tell us more how this initiative is going on in your organization. So I bring now the commonly used terms in the industry. First, we have operation technology that is associated with the set of all the set of hardware and software that is able to detect and also to cause change through the direct monitoring and control of the not only equipments but also assets, processes, and industrial events. And remembering that operation technology is different from information technology. Then we have OT security that relates to all the practices and the technology that are used to protect people, assets, and also information. And this also involves not only the monitoring, but the control of physical devices, processes, and events. And it's important, I think it's something important to bring here, is that the OT, as I said before, the OT security paradigm did not evolve together with IT. So now IT is the security is more mature in IT devices than in OT devices. The next concept that I'd like to bring here is industrial control systems. That is a segment inside of OT and relates to all the systems that are used to monitor and control industrial processes. And it is also associated with critical applications to the business, and that needs high availability. Can you imagine the impact if a plant of an industrial plant stops working because of a cyber attack or because of a security incident? These companies need high availability, and some of them works 24/7. And these industrial control systems that how we call IC and how we call the ICS as well, they are managed through SCADA. SCADA relates to what we call supervisory control data acquisition. Those systems are used in manufacturing to acquire measures and processes, measures, and variables as well. And besides that, it performs machine control through a process area or a work cell. SCADA also provides a graphical interface to the user, so they are able to check the data and also modify configurations in the systems. Well, this graphic from Gartner shows how robotic is coming further into remote operations in distant locations, like offshores, for example. And these operations, they need the human activity less. And this is also this is being boosted by technology based 5G on 5Gs and 5G, for example. And besides that, the OT market is evolving with the alignment between OT and IT. And this is how the new systems are, the cyber-physical systems have emerged. Those systems, they orchestrate sensors, computing, control, network, data analysis, to interact with the physical world. CPSs also allows performance in a secure way, in a reliable way, in a resilient way, and also, of course, in real time. That is a critical requirement from industry plans. And based on large governmental initiatives like Industry 4.0 that was created in Germany, and also the competitive forces of businesses, the appearance of CPSs, they have been conducting the growth and development of OT-based security solutions. To give you an idea of how big the industrial IoT market is, according to Industry Arc, the industrial IoT market has reached more than $120 billion last year. And by 2026, this market is expected to more than double, almost to go 3 times and reach more than $340 billion, with a compound annual growth rate of 21%. Now, what affects industrial organizations? Well, we have greater connectivity, as we've said before. So we have reached more than 24 billion connected devices. The next one is the pressure for more regulation is also growing. So we have the NERC for energy in the US, and we have a lot of requirements that we will see further in this session. We have increased cyber attacks. So not only this affects not only the other companies, but also industrial companies. And I believe that the regulations, they will pressure the companies to increasingly follow security pattern regulation and patterns in many markets. We have Brazil that has specific the data privacy regulation. We have Europe with GDPR. So and actually the number of attacks in those systems has increased more than 100% in 2016. And to make this situation even worse, we have what we call the collaboration between IT and OT. And if you remember, I said that OT is not quite mature in terms of cybersecurity, and now they are having to catch up with IT in terms of cybersecurity challenges. So we need to insert more controls in the automation process to ensure the availability of the process. And one thing is clear now: the increase of cyber attacks in operation systems and vulnerability has also is also an important aspect in this field. The last point that I'd like to bring here is the vulnerability and the tools that are available on the internet that hackers explore to perform their cyber attacks. So whenever we make a search on Google to see what are the enablers or the pillars of Industry 4.0, we can find different models, but some of them has 7 pillars, 9, 10, 11. But one thing that they have in common is that all of those models, they embrace cybersecurity, regardless of what we research. So just to give a practical example of how Industry 4.0 is on the target, we can see news from all over, and we have, of course, recent news as well. During the war now with Russia and Ukraine, we can see cyber attacks that are being used. And there's a phrase, there's a saying that says that it's not only a matter of if, but a matter of when cyber attacks will happen. So 90%, according to Ponemon Institute, 90% of industrial organizations have experienced at least one attack against their infrastructure. And cybersecurity, again, is the biggest concern on OT leaders. And they believe, and those leaders believe, that the industrial IoT security investment will grow 50% in the next year, in 2022. Well, cybercrime, it can be really expensive for companies, and this can directly affect business continuity. So according to a research, we had in 2020 a 50% increase of cybercrime costs compared to 2018. So so to catch up with the increasing threats, the cybersecurity market will need to create and develop solutions to address this issue. And the global market of industrial cybersecurity is expected to reach more than $22 billion by 2026. So some important cybersecurity aspects that I'd like to bring here in this session is that the first one, industrial systems, they perform critical tasks that can affect the continuity of operations. So we've said before that those companies need to operate 24/7, and they're always on. They exist in great scale, and they're always on. Many of the devices that are used in OT organizations, they do not have any updates from their vendors. As I said before, they don't have a security by design mentality, which this increases the chance of zero-day vulnerabilities that can be explored by malicious attackers. The next aspect that I'd like to bring here is that many operational systems in OT, they do not have the security by design principle. Many of them even don't have an access control. So they don't have like a login and password screen. You can just go directly to their management interface. So can you imagine how a malicious actor can explore this to perform a cyber attacks, how it makes easy for them to perform a cyber attacks? And many of those systems are maintained by third parties. So we have many vendors, we have many devices from different, and so we gotta have many third parties to give and to perform maintenance to those equipment. So now we know that we are in the industry 4.0 and we need cybersecurity. So now the first question comes, where should we start? Well, I might say that we're not alone, and there are many frameworks and regulations that can help us on this aspect. And even with the separation, some can call frameworks, some can call regulations. The second question here is, why should I use and choose a framework if I'm not obliged to use? So we have legislation that obliges the companies to implement those regulations, but a framework is an optional, as we said. Well, the reason is simple. When a company is compliant with a framework, is one of the best manners to start a cybersecurity program and also to build a defensive network to ensure that the industrial process stays operational. And the frameworks, they give a clear vision of the situation, a step-by-step path to reduce risks and also to keep companies away from violation and incidents. And it's important here to say that whenever a company adopts a framework, it takes some time. It takes investment in processes, in tools, in technologies, and this can take some time. So we need to plan in advance what are the frameworks that we are going to choose and how they are going to be implemented. And of course, this is not a guarantee that your company will not suffer a cyber attack, but this reduces the attack surface and allows your cybersecurity team to better detect and prevent and remediate cyber attacks. So frameworks like ISA62443, that is what we will talk about in this session. And also SIS controls and NIST, for example, those are some of the examples that industry can use to safeguard their processes based on a vast industrial knowledge. The top 20 SIS controls that now are top 18 SIS controls is a set of priority actions that contains the best practices. And probably whenever we adopt those frameworks, the chances to reduce the cyber attacks and cyber risks are increased. Now that I have introduced the frameworks that can be used in the industrial automation controls and to ensure cybersecurity, I will give now the word to my dear colleague Glenn, so he can introduce ISA, the ISA99 Committee, and the 62443 standards. Now with you, Glenn. Thank you again for your presence here, and thank you for your engagement in this session.
Absolutely. So David, you bring up some really good points that I'd just like to highlight along this one. And this one point you bring up is collaboration with between IT and OT. This is a very important concept that must be used in any organization or enterprise because the two groups have to work together. Each one has specific experiences and expertise they can contribute. You also mentioned about many devices being added into the control network, the concept of secure by design, which is very important, how this affects critical infrastructure, which is where our power and water purification and light comes from, and heat. The point there, I think, is where IT and OT begin to differ, and that's where IT deals with virtual and data and information, and OT deals with the physical control of energy and things that move. So the security concepts of IT and OT are very different, with very different risks that are involved, where with IT, if you crash a system, you reboot the system, you restore the system, you're back up and running. Where in critical infrastructure, if you crash the control system, the possibility is that people die and you have environmental damage. So there's a big difference in risks there. So how do we start to address this risk? Well, we start with a standardized approach, and that's with industrial automation and control system security. And guidance for this is provided in this standard, which is ISA/IEC 62443. And the purpose of this presentation is to give you a summary of the current status of the standard, what the recent updates from the ISA99 Committee have been for the standard, and give you just a short overview of the standard series. So the purpose of the ISA99 Committee is the primary contributor source of the content of the 62443 series. So the standards are summarized in terms of status, the current activities, and immediate plans that we have. I have basically 6 different topics that I'll review. Who the ISA committee is, how we work, what are the work products that we produce, who are the groups that are using the standards, what is the basis for the standards, and what is the current standard progress that we have. So let me go back one here. So with the ISA99 committee, so as I mentioned, is the primary source of the content of the standard series. And the standards committee has been formed since about 2002. There's currently quite a number of people who are involved in the standard series. Currently, it's made up of over 1,000 people from all different parts of industry all over the world. So we get a very wide viewpoint of how people need to address security in a control system. So anybody is free to join and contribute to the standard series. It's an open collaboration group between industry and its members. Some leaders have been committed to the work of the committee since its very foundational start in 2002, and we have others that have joined in along the way. We also have a collaboration with the IEC TC65 committee, work group 10, which takes the content that ISA99 develops and then basically makes that into a fully international standard. So it's really important to understand what the scope of the committee is and how the committee addresses the unique risks from cybersecurity of IT versus that in physical systems, or as being become known as OT. So if you take a look at this slide, I'd like to point out some very important concepts here. And one is that the committee scope for this deals with automation and control systems whose compromise could result in any or all of the following situations. So it's very important here to note these red areas, that endangerment of public or employee safety, that's not a concept that's covered by IT. Also, environmental protection is also not a concept that's covered by IT. So these are things that need to be included in the standard as additional risks because they may be shared. For example, loss of public confidence is a shared concept between IT and OT, but the information that's lost in IT could affect a different group of stakeholders, where loss of public confidence in your electric company, your water company, your energy company, all of those types of things are different types of risks. So another one is violation of regulatory requirements, and that's an area also not covered by IT. And in regulatory, we could have nuclear, we could have power regulation, we could have petrochemical regulation, environmental regulatory things that need to be addressed. Loss of proprietary confidential information. This is, again, it's a common shared IT and OT concept, but the type of data that could be lost in an OT system could be compromised in different ways. Economic loss. If you lose data, if you compromise passwords, access to financial, those are the things that are addressed in IT. But in OT, the economic loss could be more significant, where if you create a huge environmental impact, you have a different economic loss. And then finally, the impact on entities, local, state, national security. Those are things that are not covered by IT. So this goes to show some of the purposes of 62443. All right, so in the some of the members that I mentioned earlier come from all industry sectors. So what we have is we have many of these industry sectors are beginning to apply 62443 in a horizontal application of the standard series. And that includes chemicals, building automation, food and beverage, manufacturing, energy, pharmaceuticals. All of these groups are looking to apply 62443 as a standard-based approach to control systems. So how does the committee begin to tackle this problem, and how do we operate? So this is a rather complex question, and it really needs to address who are the people that we're targeting for the stakeholder community. So we saw in the previous slide the group of people that are into there, but we also have other people, roles, responsibilities within industry that are considered asset owners, service providers, and product manufacturers who all are engaged in security for these systems. So it's a collaborative development right now with the standard series. We have the ISA99 contributing the content and developing the content, and the administration develops the ANSI ISA 62443. We then work in collaboration with DC65 to develop IEC 62443. The point here is that these are the same standard, whether it's published and developed in the United States and then adopted as an IEC standard. These are the same standard, same word, same verbatim information. And we also have liaison activities with the 27,000 series, which is IT, because remember that collaboration effort that we discussed. So that's very important. We have to collaborate between the IT groups and the OT groups, because a lot of times the CISO, the CISO, is the person who gets assigned the responsibility for working with the control system security, and that requires a different set of talents. So some of the areas that we partner with within ISA is, of course, ISA 84, which is in the international standard, which is 61508 and 61511 standards for process safety. Plus, we have a lot of other ISA standards committees that we work with for alarms management, for enterprise to control systems, for batch processing, for all different types of things, automation, manufacturing, HMI, SCADA, as David mentioned earlier. We deal with our certification group, which is the ISA Standards Compliance Institute. We work with ISA GCA, which is the Global Cybersecurity Alliance. Within the United States, the National Institute of Standards Technology, IIC, IEEE, and also various international groups. So how do we break this down? What are the work products that we deal with within 62443, and how do we start to chunk this so that it's a manageable effort? So what we've done is we've taken the standard series and we've developed an initial area here, which is general descriptions. So we have technology and concepts 1-1, which is the introduction to the whole standard series. That's sort of the keystone standard that we use. 1-2 is reserved right now. It used to be the glossary. The glossary is being incorporated into 1-1. 1-3 gives us a guidance on the metrics. What are the things that you use to measure your success in your cybersecurity system? 1-4 is bringing up the concepts of what are the programs, what are the roles, the responsibilities, deliverables, and the life cycles that are involved within 62443. And then we start to break this down into subgroups, which is policies and procedures. So 2-1 deals with the asset owner. 2-2 deals with security program ratings systems to identify how successful the program is and use those metrics that we've developed up here in 1.3. 2-3 is establishing a patch management program, because patch management within the control systems is a lot different. You don't take WSUS and just go out and automatically patch your control system, because that could introduce risk of a patch that's not been tested with a particular control system, and could crash the control system. And remember when I mentioned earlier what happens when you crash a control system, you could kill people or damage environment or that type of thing. 2-4 is specific guidance for service providers. So you might have a system integrator that's building your control system. There's a lot of requirements that they need to do to make sure that they communicate back to the asset owner. And then 2-5 will be some additional information on guidance for the asset owners on how they implement their system. Then we also have at the system level, technologies, which is being restarted now. There's a TR that exists for that. We have security risk processes, which is very important to how you start to chunk the system down into parts and how you identify where your risk is in the system. That's with the purpose of 3-2. And then 3-3 identifies security programs rating using security levels. And so that's incorporated back into 3-2, and also 2-1 is important for that. And then for the system manufacturers, we have a component area that deals with what does the product supplier component manufacturer, so the people that make the instrumentation, that make the SCADA systems, that make the PLCs, what are the capabilities do they have to build into the system so that the system can be secured? So this is a very important concept, that as you secure your system, you have to begin with secure devices that have the capability of being secured. So that's sort of the quick overview of the standards. So who's actually using the standards today? And this is something that's really changed significantly in the last 12 months, where we have a lot of horizontal application of the 62443 series, and traditionally this has been mostly process. It's now moving to manufacturing and energy, transportation systems, rail, air systems, those types of things. But more importantly, David mentioned earlier about the critical infrastructure. So basically, 62443 is now being applied globally, both the US and EU and other countries across all critical infrastructure sectors as a horizontal application. And this is important because primarily people thought of 62443 as a siloed security just for the automation of process control and oil and gas and that type of thing. And what we quickly found out was across the critical infrastructure sectors, this one is defined by the Department of Health and Safety, or DHS, Department of Homeland Security, sorry. Of all of the 16 critical infrastructures that could benefit from the use of applying 62443 for security practices. So let's take a couple of minutes and look at the principal concepts that form 62443. So what are the pillars? You know, David had mentioned earlier about certain pillars that are used for security concepts. And in 62443, we have very specific pillars that are used to develop security. So within that, first off is, what are the principal roles? You know, who are the types of organizations that have to deal with security? And with that, as I mentioned earlier, we have principal roles of the asset owner, we have the service provider systems integrator, and we have the component manufacturer. So those are the principal roles within 62443. But then as we take a look at organizational structure, we also have other roles, which are work titles usually that deal with this. So the CXO suite, which is your CEO, your CISO, your chief operations officer, your chief technology officer, those are organizational titles within the principal role. So that's an important concept. We also deal with what is the security lifecycle. And this is a very important concept, because you might have multiple control systems, and each one of those will have its own life cycle, and then you'll have a different process for securing each one of those. So you may have one life cycle and one process for securing it, or if you're a very diverse portfolio organization, you could have multiple life cycles and multiple processes. So 62443 allows for that type of operation. The main focus that we deal with is, what is the system under consideration that needs security? And that allows you to begin that process of chunking the risk. So does it have an individual risk? Does it have multiple risks? What are the attack surfaces that you have to deal with? What are the vectors that could be approached? And remember that the risks in a system for control system are considerably different than than in IT. So then what are the general security concepts that you have to address in each one of those? What does operations need to address for each one of those security concepts, and how do they maintain the security in a system? This is guidance within 62443. And then how do you apply the foundational requirements to all of these things, to the life cycle, the system under consideration, applying general security concepts and operational techniques. So we start with the principal roles again. We have the asset owner, the product supplier, manufacturer, and then within other parts of the roles, we could have a maintenance service provider who could also be an operator, and I'll touch on that a little bit. We could have an integration service provider who's actually designing and building this system for the asset owner. So the asset owner may not be developing the system themselves. They could have a set of specifications, and a service provider could be building that as a systems integrator. So also the associated roles that the asset owner needs to be responsible for is, the asset owner is responsible to regulatory authorities, because there might be compliance issues. So there might be a compliance authority in with that regulatory. There might be a conformance assessor that comes in to gauge that compliance activity. But the main point here is that the asset owner is the legal entity responsible for security of the control system. So these life cycles that I talked about, how do they interact? So this diagram shows that we have basically three different life cycles that all have to interact together. Remember, I identified the different roles. So we have the asset owner role, which is over here, which is involved in this operations and maintenance, but also is involved in design, integration, commissioning, and also is working with product development, product suppliers, for selecting the components that have the capability of security. So these are life cycles in themselves. For example, the product supplier has to have products, processes in place. They have to have technology that gives and the important word here is capability of securing a system. Because if you don't use components that have security built into them, then you can't secure your system unless you have other compensating countermeasures. So in the system integrator portion, the system integrator is going to take those components, they're going to select those components, generate a system that can be manufactured and secured, provides that over to the asset owner or the operations and maintenance group. So each one of these, the systems integrator, then also has to have processes and procedures in place. They have to have knowledge and training to take advantage of the security capabilities that are developed in the products, and they have to have the knowledge and capability to transfer that information over to the asset owner, so the asset owner can continue to operate the system in a secure and safe manner. So those are some of those life cycles that we discussed, and each one of those has to interface with other parts of the life cycle. So when we take a look at system under consideration, so how do we take a look at that? Because that could be a very huge system. David mentioned about, we have many devices and Industry 4.0, and you've heard about grid automation, where we're taking a look at concepts like AGES, which is Advanced Grid Information System, and we're looking at all of these devices that are spread out across hundreds and thousands of access points. So how do you begin to take a look at where you need to apply security on a system? So you start with 3-2, and as I mentioned earlier, 3-2 is that that part of the standard that gives you the capabilities to start to break your system down into manageable pieces that can be secured. So it describes the scope of the system being addressed by the security response to a risk. The risks must be defined by the asset owner for this specific situation. So that gives you some chunking of that responsibility to identify what those risks are, where are those attack surfaces, where are those attack vectors, how do you apply defense in depth to these things. And notice that this is focused upon security risk to maintain, and this is a very important concept, to maintain the availability of control functions in the system. Because if the control functions do not operate, you don't have power, you don't have electric, you don't have lights, you don't have water. That's why control functions are so important. So in this process, we break down to the general security principles into security elements. What are the security elements that we need to address? What is a risk-based approach to mitigating the problems, the attacks, those types of things that we could have in securing a system? What type of compensating countermeasures do we need to address in this system if we don't have a native security function? How do we apply least privilege, least function? These are common concepts that you see from IT. How do we maintain essential functions, which is a term in safety? How do we apply different layers, defense in depth? And then the other one that's very important is, how do you know that your supply chain for the components that are going into your system is secure? So these are all concepts that are developed in 62443. So to further elaborate on the security concepts, we have foundational requirements that we apply. We have security program elements that break down the system. We group those into security concepts. We apply a taxonomy of how the system is actually constructed. We segment the security by establishing zones and conduits. We establish security levels. Maturity level is another area where the asset owner, the system integrator, the product manufacturer all have to have a certain degree of organizational maturity to be able to have policies, practices, and procedures in place to support the security. Security protection schemes, security and functional safety is very important. And then safety, integrity, availability, and reliability and confidentiality. These are all concepts that are sometimes shared, but mostly unique in a control system. So for foundational requirements, there's basically 7 foundational requirements that deal with identification and access control. You'll notice that that's a shared concept. Use control, system integrity, data confidentiality, restricted data flow, timely response to events, and resource availability. These are all critical concepts. Some are IT, many are very unique to control systems, so they're addressed specifically in 62443. Security program elements. Organizational, these, if you'll notice that these have abbreviations that are tied to each particular area. So how does the organization deal with security? How does configuration affect your security? What type of communication networks exist? Do you have component security? Remember that capability that I discussed. How do we protect data? The data here could be something as critical as what is the recipe going into a pharmaceutical product that you're going to put in your mouth. You know, if that's not secured and can be hacked, then there's a danger to the public. How do you maintain user access control? This is different than IT because you might need physical access control and other methods. And you can't have necessarily a control station that has a series of passwords that are changing daily if someone has to respond immediately to a control system event. So that's a different risk. How do you handle events? Events have to be handled differently because in a control system, if something is happening that could cause life or environmental damage, you have to respond to it a little bit differently than cutting off the control system communication like you would with IT. And then how do you maintain that system integrity and availability? That's very important because control systems must be available 100% of the time, and they must be reliable 100% of the time, or there has to be fault handling for that. So this next chart basically breaks down those areas. I won't get into a lot of this area, but all the concepts that are brought to the table in previous slides are addressed here. I mentioned taxonomy. This is just an example of how a system is broken down from an IACS and what areas this brings up for an automation solution. What products and components are brought into the system, and policies and procedures, which are very important to maintaining security. So the concept of zones and conduits, again, this is a means of defining segmentation. This is how you break down the system so that you can manage the security in smaller pieces. Security levels address with casual or coincidental violations of security, passwords, those types of things, all the way up to nation state attacks. So this is, if you might have a regulatory area such as nuclear, there's very, very specific things that you need to address, and those complement the process in 62443. So another concept I mentioned was maturity levels. This deals with the organizational capability of a group to actually implement security. So this deals with 4 different levels here. There's if you're actually actively managing, and continuous improvement is the last level on that one. So other important concepts, as I mentioned, safety is a very critical aspect of this. Integrity, availability, reliability, and confidentiality. The addition of safety is very critical here, and functional safety and security is a keystone of control system security. So I mentioned security protection schemes as brought out in a technical report 2-2 and the rating system on that. So where do things stand right now? I'll just give a quick review and we'll go out to if we have any time for questions on that. But for right now, 1-1 is currently integrating comments and plans to have this out for release, hopefully by the end of 2022. 2-1 is also in the process of incorporating comments. We need to have this ready by the middle of the year. Protection ratings is a technical report that's in process of being reformatted. 3-3 for security levels is in the process of a second edition. Patch management system is right now responding to comments for this to be a full standard. IIoT is a technical report coming out. This will address cloud implications and a lot of those, as David mentioned, those many devices that Industry 4.0 is bringing out. The metrics is basically soon to release. 1-5, some of you may have heard about different profiles. This will establish rules for using 62443 in different industry profiles. And this basically means different industries like power, energy, manufacturing, that type of thing. And we have this thing called micro-learning modules that we're dealing with to explain some concepts. We have a group that deals with consistency across the series that works with the structure, the terminology, common foundational concepts, common models, requirements, and also to keep a common approach to our framework and our roadmap. So that goes over basically where we are with the committee and most of these things. So I think in conclusion, I just want to bring out a couple of points here. And one is that the ISA99 committee is the content originating committee for the 62443 series, and that's whether or not it's a national standard as ANSI or whether or not it's an international standard as IEC. That content comes out of the ISA99 committee. The 62443 series was not developed for any particular industry, but rather as a security guidance to be applied to any control system. So this is where we get a horizontal application. And in order to help various positions within an organization understand 62443 concepts, we've started these micro-learning modules that introduce people to the basic concepts. And those are, as I just received notice about an hour ago, are just now becoming available for free through YouTube and a couple of other areas through ISA as a free benefit to anybody. So with that, I'll turn that over to David and for questions if we have time.
Excellent. Thank you for your presentation, Glenn. That was really, really insightful and helpful. So I hand over to you, Thais. Bring up the questions. Do we have time for any?
Hi guys, I would like to start. Thank you both for the great content. Unfortunately, we're running out of time and we got some questions, but I selected one just for us to answer now, and all the other questions will be answered by email, so don't worry guys. Okay, so let's see one here. How to address cybersecurity aspects in legacy OT systems without the security by design aspects implemented?
Mm-hmm.
Do you want to answer that, Glenn?
Sure, absolutely. So, you know, one of the issues that we have with control systems is that a lot of the control systems were designed before the idea of security was thought. So you have to have this concept of designing and bolting on security, and the devices may not have the capability of a password or something like that. So we have the concept of compensating countermeasures where additional devices can be added to the system to monitor those devices. Maybe map out what their characteristics are, how they perform, and alert people to if something's going wrong. So there are ways. There's basically two concepts, as David had mentioned, was the secure by design process. The second one, of course, is the bolt-on security, and you need to still take that system and look at compensating countermeasures.
Excellent. I gave an example during my presentation about, for example, access control. So whenever a user needs to access the configuration interface of a system, they can, for example, they sometimes even don't have the access control part. They don't have a username and password. Well, in this aspect, we can use, for example, a solution to address this aspect. So we can use, for example, an identity and access management, privilege access management tool. So there are cybersecurity tools that are being developed to assist and to help industrial organizations to address this aspect, that is the lack of the security by design aspect when developing the OT equipment and devices.
Exactly. Yeah, and I think during my presentation, I stressed the point that with the control system, you may not have, it might not be acceptable risk to have a password on a control station. So you have to have other compensating countermeasures, and that might be maybe you place a guard at the door, maybe you have card key access, you have background checks of all of those people you put into the system. You maintain that, because when you have to respond to a control system alert, you don't want somebody trying to figure out, oh gosh, what was my password for yesterday that I had to change today, and then the system crashes.
Yeah, you're right. Any other
Okay,
questions,
guys?
guys? Do we have time or not?
Sorry, guys, but we don't have more time for another question, but we got another questions. And as I already said, you all will be answered. It will all be answered by email. So once again, I would like to thank you so much, David and Mr. Merrill, for the amazing content and for the amazing time that we have in here. So thank you very much. And I would like to thank you, all of you, for your presence and time. It's great for us in Senha Segura to know that more and more people and companies are concerned about cybersecurity. And I would like to just take one moment to take this opportunity to present once again our Fraud Prevention Month campaign that ends today. Yeah, and we here know that March is the month of fraud prevention. And here in Senha Segura, we want to take this opportunity to emphasize the importance of good information and security practices. And that's why I gave you guys the link I let in the field in the Zoom. So please check it out, and you have our amazing content. Once again, guys, thank you very much. Thank you, all of you, and see you in our next webinar. Bye-bye.
Great. Bye-bye.
Thank you very much. Bye-bye, Glenn. Thank you. Cheers.